What if I told you some of the strangest places in our solar system aren't planets at all, but they're moons? Picture this: vast, icy worlds with hidden oceans, volcanoes spewing alien plumes, and surfaces scarred by forces we barely understand. These aren't scenes from science fiction, they're real, and they're orbiting planets right in our cosmic backyard. Among the dozens of moons circling Jupiter, Saturn, and beyond, a select few stand out as genuine enigmas, places where the rules of physics seem to twist, where the potential for life flickers in the darkness, and where every new discovery leaves scientists questioning what they thought they knew. Think about it. We often focus on Mars or distant exoplanets when we imagine alien worlds, but some of the most jaw-dropping mysteries are much closer than we realize. Take Europa, for instance, a moon coated in ice, but beneath that frozen shell, there's an ocean holding twice as much water as all of Earth's seas combined. Or Triton, where rivers of liquid methane carve valleys into a landscape eerily similar to our own, yet utterly alien. These aren't just barren rocks, they're dynamic worlds with atmospheres, weather, and even the ingredients for life. And the craziest part, we've only scratched the surface of what's out there. That's exactly why we're diving deep into the 25 most mysterious moons in our solar system today. From explosive geysers on Enceladus to the chaotic, cracked terrain of Miranda, each of these celestial oddities has a story to tell, one that could rewrite textbooks and redefine our place in the cosmos. Some might even hold the keys to answering humanity's oldest question: are we alone? So buckle up. Over the next few minutes, we'll explore these bizarre, beautiful worlds, uncover the secrets they're hiding, and reveal why they might just be the most fascinating places you've never heard of until now. Among Jupiter's many moons, one stands out as a cosmic inferno, Io. This isn't your average crater-pocked world. Instead, it's a seething ball of fire, constantly reshaped by eruptions so powerful they dwarf anything on Earth. Imagine a place where volcanoes don't just erupt occasionally, but hundreds of them spew lava and sulfurous plumes non-stop, painting the surface in surreal yellows, oranges, and reds. That's Io, the most volcanically active body in our entire solar system, and its chaos is all thanks to a gravitational tug-of-war with Jupiter. Here's why Io is such a violent spectacle. Locked in orbit around Jupiter, it's relentlessly squeezed by the planet's monstrous gravity, while also being pulled by neighboring moons like Europa and Ganymede. This constant stretching and compressing generates immense tidal forces, heating up Io's interior like a ball of molten rock. The result, over 400 active volcanoes, some blasting sulfur plumes hundreds of kilometers into space, so high they've been spotted by telescopes from Earth. But what really boggles the mind is Io's ever-changing surface. Unlike most moons where craters stick around for billions of years, Io's landscape is constantly being buried under fresh lava flows, evaporating sulfur dioxide frost and volcanic fallout. Some eruptions are so intense they've created lava lakes dozens of kilometers wide, glowing in the darkness like open wounds on the moon's fiery skin. Even the thin atmosphere, mostly sulfur dioxide, is continually replenished by these eruptions, only to freeze into frost when Io swings into Jupiter's shadow. What makes this moon even stranger is the sheer diversity of its volcanic activity. Some vents ooze lava in slow, creeping rivers, while others explode with enough force to launch debris at escape velocity, literally hurling material into space. And the temperatures, lava flows here can reach over 1,600 degrees Celsius, hotter than anything we see on Earth today. Yet for all its fury, Io holds clues to our solar system's past. Studying its eruptions helps scientists understand not just how tidal forces shape worlds, but how similar processes might have influenced other moons and even early Earth. It's a reminder that even in the coldest reaches of space, fire and chaos can reign supreme, and that sometimes the most alien landscapes are right in our own cosmic neighborhood. While Io burns with relentless volcanic fury, its neighboring moon Europa presents a stark contrast, a world frozen in ice but hiding secrets that could rewrite our understanding of life itself. Beneath Europa's cracked, pale surface lies something astonishing, a global ocean kept liquid by the same tidal forces that torment Io. But here, instead of fire, there's water, more than twice the volume of all Earth's oceans combined, locked under an icy shell up to 24 kilometers thick. What makes Europa so tantalizing isn't just the presence of water, but what might be thriving in it. Sunlight never reaches those dark depths, yet hydrothermal vents on the ocean floor, much like those in Earth's deepest seas, could provide energy and chemical nutrients for life. Scientists speculate that if extremophile organisms can survive near Earth's volcanic vents, why not here? The ingredients are all present: liquid water, heat, and organic molecules detected in Europa's plumes. Speaking of plumes, those might be our best clue. Hubble Space Telescope observations have caught glimpses of water vapor erupting from Europa's south pole, spraying more than 160 kilometers into space. These geysers suggest the ocean isn't entirely sealed away. Fractures in the ice might allow water to escape, offering a shortcut for future missions to sample Europa's hidden sea without drilling through miles of ice. And those missions are coming. NASA Europa Clipper, set to launch in the next few years, will perform dozens of close flybys, mapping the moon's surface and analyzing those plumes for organic material. Even more ambitious plans, like a potential lander, could one day search for microbial life directly. The European Space Agency's Jupiter Icy Moons Explorer, or JUICE, will also study Europa alongside Ganymede and Callisto, adding another layer of data to this celestial detective story. But Europa's mysteries don't stop at its ocean. The moon's surface is a labyrinth of ridges, fractures, and chaotic terrain, suggesting the ice shell might be shifting or even harboring pockets of slushy water closer to the surface. Some regions look like Earth's Arctic ice flows, broken apart and refrozen in bizarre patterns. Then there's the reddish-brown material streaking Europa's cracks, possibly salts or organic compounds brought up from the ocean below, staining the ice like cosmic tea leaves waiting to be read. The sheer possibility that life could exist so far from the sun in an ocean cut off from sunlight, warmed only by the flexing of tidal forces, challenges everything we thought we knew about where life can thrive. If Europa's dark waters hold even the simplest organisms, it would mean life isn't a rare fluke confined to Earth, but a cosmic inevitability waiting wherever conditions are right. That's why this icy moon isn't just another satellite of Jupiter. It's a beacon calling us to look deeper and maybe, just maybe, find we're not alone in the universe after all. Moving beyond Europa, we encounter a moon so massive it dwarfs entire planets, Jupiter's Ganymede. This isn't just another icy satellite, it's a world larger than Mercury, with a footprint that eclipses Pluto. If Ganymede orbited the Sun instead of Jupiter, we'd likely classify it as a planet. But size isn't its only claim to fame. Ganymede is the only moon in our solar system known to generate its own magnetic field, a feature usually reserved for planets like Earth or Jupiter. What creates this magnetic field? Deep beneath Ganymede's icy crust lies a hidden ocean of liquid saltwater, kept warm by tidal heating and radioactive decay in its rocky core. But unlike Europa's subsurface sea, Ganymede's ocean is sandwiched between layers of ice, with estimates suggesting it could be 100 kilometers deep, 10 times the depth of the Mariana Trench. Even more intriguing, this ocean might be stratified with different layers of salinity and density, creating a liquid labyrinth of currents and chemistry. The moon's surface tells an equally fascinating story. Ganymede's terrain is a patchwork of ancient, dark regions pockmarked by craters and brighter, younger grooves where tectonic forces have reshaped the landscape. These grooves stretch for thousands of kilometers, some as wide as a city, forming intricate patterns that suggest Ganymede's icy shell has fractured and shifted over time. Then there's the magnetic mystery. Ganymede's field interacts with Jupiter's colossal magnetosphere, creating auroras that dance around its poles, much like Earth's northern lights, but fueled by a celestial tug-of-war between two magnetic giants. Data from NASA Galileo spacecraft revealed these interactions, along with evidence that Ganymede's ocean might be electrically conductive, amplifying its magnetic influence. But here's the real kicker: Ganymede's ocean isn't alone. Recent observations hint at multiple layers of liquid water separated by ice, creating a complex onion-like interior. Some scientists even speculate that these submerged layers could host different environments, perhaps some more hospitable to life than others. When you step back, Ganymede isn't just a moon. It's a planetary body in its own right, with geology as complex as any rocky world and secrets that could redefine how we think about ocean worlds. From its magnetic personality to its hidden seas, this colossal moon proves that sometimes the most extraordinary discoveries aren't made on planets, but in their shadows. While Ganymede and Europa steal much of the spotlight, Jupiter's Callisto offers a different kind of allure, not for what's changing, but for what stayed the same. This moon is a frozen time capsule, its surface so heavily cratered it looks like it's been pelted by cosmic bullets for billions of years. Unlike its dynamic siblings, Callisto shows no signs of volcanic activity or tectonic shifts. Instead, it's a relic of the solar system's violent past, with one of the oldest and most unchanged landscapes we've ever observed. Every crater tells a story of ancient collisions, preserved in ice and rock like scars that never healed. But don't let its quiet exterior fool you. Beneath that battered shell, Callisto might be hiding secrets of its own. Scientists suspect a subsurface ocean lies trapped under 100 to 200 kilometers of ice, kept liquid by the same tidal forces that heat its neighbors. Unlike Europa's ocean, though, Callisto's isn't churning against a thin, active crust. It's deeper, darker, and far more isolated, a buried sea with no plumes or cracks betraying its presence. Yet the Galileo spacecraft detected subtle magnetic fluctuations hinting at salty, conductive water below, and if confirmed, that ocean could be vast, potentially overlapping with layers of slush or even pockets of high-pressure ices. What makes Callisto especially intriguing is its potential as a staging ground for future human exploration. Unlike Europa or Io, it sits just far enough from Jupiter's intense radiation belts to be less hazardous for long-term missions. Its stable, geologically quiet surface, free from volcanic eruptions or shifting ice, could offer a safer place for habitats or research stations. Imagine astronauts landing on those ancient plains, drilling through the ice to sample an ocean untouched by sunlight for eons, or using Callisto as a base to study Jupiter and its other moons up close. NASA and other space agencies have even floated concepts for robotic landers or crewed outposts here, drawn by its relative safety and strategic location. Then there's the puzzle of its formation. Callisto's interior appears only partially differentiated, meaning its heavier elements haven't fully sunk to form a dense core like most moons or planets. This suggests it never experienced the intense heating that reshaped its siblings, leaving it as a kind of cosmic fossil, a snapshot of what the early solar system's building blocks might have looked like. Some researchers speculate that studying Callisto could reveal clues about how Jupiter's moons assembled in the first place, or even how gas giants themselves grow from swirling disks of debris. From its silent, cratered surface to the enigmatic ocean beneath, Callisto is a world of quiet contradictions. It's ancient yet hiding modern-day mysteries, seemingly inert yet possibly harboring liquid water, neglected by comparison but perhaps the most practical destination for humanity's next giant leap. In a system full of fire and ice, Callisto reminds us that sometimes the greatest discoveries are waiting in the places we least expect, not in the chaos but in the calm. If you thought Earth had a monopoly on rain, rivers, and lakes, Titan would like a word. Saturn's largest moon isn't just another frozen rock. It's a world so eerily Earth-like yet profoundly alien that scientists often call it a mirror universe of our own planet. Imagine a place where the air is so thick with nitrogen you'd feel like you're swimming rather than walking, where liquid methane pools into vast seas, and where hydrocarbon dunes stretch farther than Earth's deserts. This isn't science fiction, this is Titan, a place where chemistry defies expectations and the building blocks of life might be assembling right under our noses. What sets Titan apart isn't just its landscape, it's the only moon in our solar system with a dense atmosphere, 1.5 times thicker than Earth's. Smoggy orange skies shroud the surface, filled with organic molecules like ethane and propane that rain down in slow, syrupy droplets, but the real showstopper. Titan's methane cycle. Just as water evaporates, forms clouds, and falls as rain on Earth, methane does the same here, only at temperatures close to -180 degrees Celsius. Radar images from NASA Cassini mission revealed sprawling methane lakes near the poles, some deeper than the Great Lakes, carved by rivers of liquid hydrocarbons over millennia. Then there's the weather. Titan's seasons last for years, driven by Saturn's 30-year orbit around the Sun. During winter, methane clouds gather over the South Pole, unleashing storms that flood valleys with liquid methane. In summer, the cycle reverses, evaporating these lakes and sending vapor northward, a slow-motion dance of evaporation and condensation that feels hauntingly familiar. Even Titan's dunes, sculpted by winds, resemble Namibia's Namib Desert, except they're made of dark, plastic-like sand called tholins, organic compounds forged in the moon's upper atmosphere. But here's where Titan gets truly revolutionary: its chemistry. The moon's atmosphere is a factory for complex organic molecules, churning out compounds like acetylene and hydrogen cyanide, ingredients thought to be crucial for life's origins. Some scientists speculate that Titan's methane lakes could host probiotic chemistry, where these molecules interact in ways similar to early Earth before life emerged. There's even evidence of subsurface water kept liquid by tidal heating, raising the wild possibility of two separate chemical engines, one water-based, one hydrocarbon-based, operating side by side. The implications are staggering. If life can emerge in Titan's frigid methane seas or beneath its icy crust, it would redefine our understanding of biology's limits. That's why missions like Dragonfly, NASA, upcoming rotorcraft are so pivotal. Set to launch in the next decade, it will hop across Titan's surface, sampling organic-rich regions and sniffing the air for clues. Every discovery could inch us closer to answering whether life isn't just a fluke of Earth but a cosmic inevitability, waiting wherever chemistry and energy intertwine. Titan isn't just another moon. It's a laboratory, a time capsule, and a challenge to everything we assume about habitable worlds. In its methane tides and organic haze, we might just find the recipe for life itself, written in a language we're only beginning to decipher. If Europa has a rival in the search for alien life, it's Saturn's tiny moon Enceladus, a place where the universe seems to be screaming its secrets into the void. This small, icy world, barely 500 kilometers across, should be frozen solid. Instead, it's one of the most geologically active bodies in the solar system, firing massive plumes of water ice and organic compounds hundreds of kilometers into space from fractures near its south pole. These aren't just occasional spurts, they're continuous eruptions, feeding one of Saturn's iconic rings with a constant supply of fresh ice particles. And hidden beneath that icy crust, a global ocean warmed by hydrothermal vents where conditions might just be perfect for life to take hold. The discovery of these geysers was one of the Cassini mission's most jaw-dropping moments. As the spacecraft swooped past Enceladus, its instruments detected towering jets bursting from tiger stripe, like fractures in the ice cracks dubbed sulci that glow warmer than the surrounding terrain. Analysis revealed these plumes aren't just water vapor, they're laced with sodium chloride table salt and silica nanoparticles, telltale signs of hydrothermal activity on the ocean floor below. On Earth, similar vents called black smokers teem with bizarre, heat-loving organisms thriving in total darkness. If life exists on Enceladus, this is where it would be, clinging to mineral-rich chimneys, fueled by chemical energy rather than sunlight. But the real bombshell came when Cassini's mass spectrometer detected molecular hydrogen in the plumes, a gas that on our planet often serves as food for microbial life. Combined with carbon dioxide and organic molecules also found in the jets, Enceladus has all the key ingredients for methanogenesis, a metabolic process used by some of Earth's oldest organisms. Scientists couldn't have designed a more promising laboratory for extraterrestrial biology if they tried. What makes Enceladus especially compelling is accessibility. Unlike Europa, where sampling the ocean would require drilling through kilometers of ice, this moon is practically handing us its secrets. Those geysers eject material directly into space, offering a free sample of the subsurface ocean's chemistry. Future missions could fly through the plumes, analyzing their contents for amino acids or even cellular material. No lander required. Some proposals suggest melting probes or tiny submarines, but for now, simply catching more ejecta might be enough to find smoking gun evidence of life. The ocean itself is another marvel. Tidal forces from Saturn squeeze Enceladus, generating enough heat to keep the water liquid despite the moon's distance from the sun. Models suggest the sea could be up to 10 kilometers deep, capped by an ice shell averaging 20 to 30 kilometers thick, except at the South Pole, where it's just a few kilometers thin, allowing those explosive plumes to punch through. And the water isn't just lukewarm. Some estimates put it near 90 degrees Celsius at the vents, creating cozy pockets where extremophiles could thrive. Yet Enceladus isn't without its puzzles. The moon's surface is bizarrely young, with some regions showing fewer craters than Earth's own ice sheets, evidence of constant resurfacing. Some scientists speculate this activity might be episodic, with the moon cycling between quiet periods and eruptive outbursts over millions of years. There's also the question of how long its ocean has existed. If its ancient life might have had time to emerge, if it's geologically short-lived, the clock could still be ticking. For now, Enceladus stands as one of our best bets for finding life beyond Earth, a tiny, icy world with a heart of liquid water and a habit of spilling its guts into space. Every plume we analyze, every salt grain we scrutinize, brings us closer to answering whether we're alone in the cosmos. And if one day we find even microbial organisms dancing around those alien vents, it would mean life isn't a rare accident confined to our pale blue dot. It's a cosmic imperative waiting wherever there's water, energy, and time. At first glance, Saturn's moon Mimas seems like it's straight out of a sci-fi movie. Its most striking feature, the Herschel crater, stretches nearly 1/3 of the moon's diameter, so vast it gives Mimas an eerie resemblance to the Death Star from Star Wars. But this isn't special effects, it's real. The crater's walls tower over 5 kilometers high, with a central peak jutting even higher, as if the moon barely survived a cosmic collision of unimaginable force. And yet, despite this apocalyptic scar, Mimas holds an even bigger mystery. It wobbles. Scientists first noticed this odd movement in data from NASA Cassini spacecraft. Instead of rotating smoothly, Mimas rocks back and forth slightly as it orbits Saturn, a motion that defies expectations for a solid, icy moon. This tiny wobble, known as libration, suggests something strange is happening beneath its battered surface. Two leading theories have emerged, each more fascinating than the last. The first, a hidden global ocean like those on Enceladus or Europa, sloshing beneath 20 to 30 kilometers of ice. If true, it would mean Mimas, long considered a frozen, geologically dead rock, could secretly harbor liquid water kept warm by Saturn's relentless tidal forces. But there's a catch. Most ocean moons show signs of internal activity, cracks, geysers, or youthful terrain. Mimas, on the other hand, looks ancient and undisturbed, its surface marred only by craters with no hint of resurfacing. That's where the second theory comes in. Maybe Mimas's core isn't spherical. Instead, it could be oblong or irregular, shaped like a squashed football, creating that distinctive wobble as the moon spins. Here's where things get even weirder. If Mimas does have an ocean, it would have to be incredibly young, geologically speaking, to explain the lack of surface evidence. Some calculations suggest it might have formed within the last 25 million years, a blink of an eye in cosmic terms. That would make it a newborn compared to the ancient oceans of Europa or Triton, raising wild questions about how and why liquid water could appear so late in a moon's life. Then there's the Herschel crater itself. The impact that created it nearly shattered Mimas, leaving fractures on the opposite side of the moon, cracks that might reach all the way to a subsurface sea if one exists. The energy from that collision would have been enough to melt vast amounts of ice, possibly kickstarting an ocean that's still lingering today. So which is it, a hidden ocean or a weirdly shaped core? Upcoming missions like NASA's proposed Enceladus orbiter could shed light on Mimas's secrets by measuring its gravity field or hunting for chemical traces in Saturn's rings. For now, this tiny moon remains a paradox, a seemingly quiet world that might be hiding chaos beneath its icy shell. Whether it's water or a warped core causing that wobble, one thing's certain: Mimas proves that even the most unassuming objects in space can hold universe-shaking surprises. If you're looking for a moon that defies every expectation of order in the solar system, Saturn's Hyperion is your perfect candidate. This isn't just some pockmarked rock, it's a cosmic oddity, a spongy, misshapen lump of ice and dust tumbling chaotically through space like a drunken asteroid. At first glance, Hyperion looks like it's been through a celestial blender, its surface pitted with deep, irregular craters that give it an almost porous texture, as if some giant hand had squeezed it too hard. But this bizarre appearance is just the beginning of its mysteries. What really sets Hyperion apart is its rotation, or lack thereof. Most moons spin predictably, keeping one face locked toward their parent planet. Not Hyperion. It wobbles and flips erratically, its axis of rotation shifting so wildly that no two orbits are the same. Imagine throwing a lopsided football in zero gravity, watching it tumble end over end with no rhythm or pattern. That's Hyperion, caught in a gravitational dance with Saturn and its larger moons that leaves it spinning without any discernible logic. Astronomers call this chaotic rotation, and it's one of the only known examples in our solar system. But the weirdness doesn't stop there. When NASA Cassini spacecraft flew by in 2005, it made another startling discovery: Hyperion's surface is charged. As the moon drifts through Saturn's magnetic field, it builds up an electrostatic charge strong enough to repel tiny particles of dust. This creates strange, dark patches where material has been blasted away, leaving behind eerie, shadowed voids. Even more puzzling, the charged regions seem to align with Hyperion's deepest craters, suggesting some unseen interaction between its porous interior and the space environment. Scientists still aren't entirely sure what's causing this phenomenon, but it's yet another quirk that makes this moon unlike anything else we've seen. Then there's the matter of its composition. Hyperion is incredibly lightweight for its size, with a density so low it's barely more than half that of water. This suggests it's not a solid chunk of rock and ice, but rather a loosely packed rubble pile, filled with caverns and hollows that make up nearly half its volume. Some researchers think these gaps might be the result of ancient impacts blasting material away without compacting the moon's interior, leaving behind a fragile, honeycomb-like structure. Hyperion's oddities don't end with its physical traits. Even its color is a mystery. Unlike most icy moons, which are pale or reflective, it sports a reddish-brown tint, likely from organic compounds like hydrocarbons coating its surface. But how these molecules got there, whether from cosmic rays breaking down surface ices or from some deeper chemical process, remains an open question. In a solar system full of stunning, sculpted worlds, Hyperion stands out precisely because it refuses to conform. It's a moon without rules, a celestial rebel spinning wildly through space while its surface crackles with unseen energy. And yet, for all its chaos, it holds valuable clues about how small bodies evolve, how electrostatic forces shape planetary environments, and maybe even how the building blocks of life spread through the cosmos. Unpredictable, enigmatic, and utterly unique, Hyperion reminds us that sometimes the most fascinating discoveries come from the places that play by their own rules. Saturn's moon, Iapetus, is a cosmic enigma wrapped in black and white mystery, quite literally. Unlike any other moon in our solar system, its surface is split into two dramatically different shades. One hemisphere is as dark as fresh asphalt, while the other gleams like freshly fallen snow. This striking duality gives Iapetus the appearance of a celestial yin-yang, but the reasons behind this contrast are even more fascinating than the visuals. The dark region, nicknamed Cassini Regio after the astronomer who first observed it in the 17th century, reflects less than 5% of sunlight, darker than charcoal, while the bright side reflects over 60%. Early theories suggested volcanic activity might be responsible, but the truth turned out to be far more unexpected. The leading explanation, Iapetus is painting itself dark with help from an unlikely source. Scientists believe the moon's leading hemisphere, the side that faces forward as it orbits Saturn, is being coated by dust flung off Phoebe, one of Saturn's outer moons. Phoebe's dusty debris, rich in carbon-based compounds, spirals inward over time, and Iapetus sweeps it up like a windshield catching highway grime. But here's the twist: the dark material absorbs sunlight, warming the surface just enough to trigger a runaway feedback loop. As the darkened ice sublimates, turning directly from solid to gas, it leaves behind even more concentrated dark residue, amplifying the contrast. Meanwhile, the bright trailing hemisphere remains pristine, its icy surface untouched by this cosmic pollution. But Iapetus's oddities don't end there. Straddling its equator like a monstrous seam is an equatorial ridge that defies easy explanation. This towering feature, reaching up to 20 kilometers high and stretching over 1,300 kilometers long, gives the moon the uncanny appearance of a walnut. Some researchers argue it could be the remains of a collapsed ring system, debris that once encircled Iapetus before raining down and freezing into place. Others propose it's a relic of the moon's formation, a frozen bulge from when Iapetus spun much faster, its equator flinging material outward before solidifying. There's even a wilder idea that the ridge formed when Iapetus's subsurface ocean froze, expanding and cracking the crust like an overfilled ice cube tray. The ridge isn't just a geological curiosity, it's a record of violence. Impact craters along its slopes show no signs of erosion, suggesting the structure is ancient, possibly dating back billions of years. Yet its sheer height and sharp edges imply little weathering, as if time itself forgot to wear it down. This paradox has left planetary scientists scratching their heads. How could something so old look so pristine? The answer might lie in Iapetus's distance from Saturn. Unlike active moons like Enceladus, it's too far for tidal forces to reshape its surface, leaving its scars and secrets frozen in time. Then there's the question of Iapetus's shape. Most moons are rounded by their own gravity, but Iapetus is oddly squashed with a bulging equator that hints at a turbulent past. Some models suggest it might have once had a moonlet of its own, a smaller companion whose gravitational pull distorted Iapetus before a catastrophic collision scattered debris into Saturn's rings, or perhaps created that infamous ridge. What makes Iapetus so compelling isn't just its mysteries, but how they intertwine. The dark staining, the equatorial ridge, the odd shape, they're all clues to a history of cosmic theft, ancient cataclysms, and geological sleight of hand. Every image from Cassini's flybys reveals new wrinkles in the story, from the way the dark material seems to pool in crater floors to the eerie smoothness of the bright terrain. It's a reminder that even in the stillness of space, worlds are shaped by drama collisions, theft, and forces we're only beginning to understand. And for Iapetus, that drama is written in black and white, a stark testament to the chaos lurking beneath the calm. If moons had identity crises, Uranus's Miranda would top the list. This isn't your typical cratered orb, it's a Frankenstein's monster of a moon, stitched together from geological fragments that shouldn't coexist. Imagine a world where 20-kilometer high cliffs dwarf Mount Everest, where canyons plunge deeper than the Grand Canyon, and where smooth plains abruptly collide with jagged ridges like mismatched puzzle pieces. That's Miranda, a celestial patchwork so bizarre it looks like it was shattered and haphazardly glued back together by a careless cosmic hand. The most striking features: coronate giant chevron-shaped regions of parallel ridges and grooves that resemble racetracks carved into the moon's icy surface. These sprawling formations, some spanning 200 kilometers, have no parallel anywhere else in the solar system. One theory suggests they're the scars of ancient upwellings, where warmer ice from Miranda's interior oozed upward like toothpaste, warping the crust before freezing into these bizarre patterns. Others propose they're the aftermath of colossal impacts that melted vast sections of the moon, leaving behind these wrinkled reminders as the slush refroze. But the real head-scratcher is Verona Rupes, a cliff face so sheer and towering that if you dropped a rock from its edge, it would take a full 10 minutes to hit the bottom. This isn't just steep terrain, it's the tallest known cliff in the solar system, a vertigo-inducing monument to whatever cataclysm tore Miranda apart. The strangest part, some sections of these cliffs gleam with freshly exposed ice, while others are coated in dark, carbon-rich material, suggesting Miranda didn't just fracture, it turned itself inside out in the process. What could have caused such extreme geology? The leading theory involves a violent game of celestial bumper cars. Miranda might have been shattered multiple times by colossal impacts, only for its fragments to slowly coalesce under their own gravity, creating this jumbled terrain. Each collision would have scrambled the moon's layers, bringing deep mantle material to the surface and burying crustal ice beneath new topography. Some models even suggest tidal heating from Uranus played a role, flexing Miranda's interior until it cracked like an overworked ice cube. Yet Miranda's diversity goes beyond its scars. Its surface is a time capsule of geological epochs, with some regions dating back 4 billion years, nearly as old as the solar system itself, while others appear startlingly young, reshaped by processes we've yet to fully understand. The contrast is so stark that flying over Miranda would feel like hopping between different worlds. One moment you're gliding over ancient, cratered highlands, the next you're navigating a labyrinth of freshly formed canyons, their walls striped with layers of ice and rock like a frozen layer cake. What makes Miranda truly special isn't just its chaos, but what that chaos reveals. Most moons show us tidy stories of gradual evolution, but Miranda screams of catastrophe, survival, and rebirth. Its jumbled terrain is a testament to the violence lurking in what we often assume is a serene cosmic neighborhood, proving that even small moons can harbor epic histories. Every cliff and canyon whispers secrets of collisions that should have been fatal, of forces that reshaped this world beyond recognition, and in doing so, created one of the most geologically thrilling landscapes we've ever laid eyes on. Of all the moons in our solar system, Neptune's Triton is the ultimate rebel, a world that doesn't just break the rules, it flips them upside down, literally. While most moons orbit their planets in the same direction as the planet's rotation, Triton spins backward, a phenomenon astronomers call a retrograde orbit. This isn't just a quirk, it's a glaring clue that Triton wasn't born alongside Neptune. Instead, it was likely kidnapped from the Kuiper belt, that distant realm of icy leftovers beyond Pluto, and forced into Neptune's gravitational grip billions of years ago. Imagine a cosmic heist so dramatic it left Triton forever locked in this backward dance, a permanent outsider in Neptune's family of moons. But Triton's defiance doesn't stop there. This moon is geologically alive, spewing towering plumes of nitrogen gas and dark dust up to 8 kilometers high geysers powered not by heat but by sunlight. As Triton's surface warms during its rare summers, sunlight vaporizes the nitrogen ice beneath its crust, building pressure until it erupts through vents, carrying streaks of organic material with it. These aren't just sterile jets, they're evidence of a dynamic world where even the faintest touch of sunlight can trigger explosive change, and the landscape they leave behind. A patchwork of cantaloupe-like terrain, wrinkled, dimpled plains, interspersed with smooth, frozen lakes of nitrogen and water ice, as if the moon's surface can't decide whether to be ancient or newborn. Then there's the atmosphere, thin but defiantly present. Triton's hazy envelope of nitrogen and methane is so tenuous you'd need a pressure suit to survive, yet it's enough to support wind-driven streaks of dark material across the ice like ghostly fingerprints of unseen storms. What makes this even stranger is that Triton's atmosphere shouldn't exist at all. At -235 degrees Celsius, most gases would freeze solid and crash to the surface. But here, the nitrogen lingers, a whisper-thin shroud that ebbs and flows with the seasons, defying the cold through some alchemy we're still unraveling. Beneath this icy chaos, another mystery lurks, a possible subsurface ocean. Triton's retrograde orbit means Neptune's gravity is slowly tugging it closer, flexing its interior with tidal forces that could be keeping a layer of liquid water sloshing beneath the crust. If true, it would join Europa and Enceladus as another potential haven for life, a salty, dark abyss warmed by the same forces that are dooming Triton to eventual destruction. In about 3.5 billion years, Neptune's pull will rip Triton apart, transforming it into a gleaming ring system. But for now, this captured wanderer remains one of the most active, enigmatic worlds in the outer solar system, a frozen maverick with the heart of a rebel and the scars to prove it. Pluto's largest moon, Charon, isn't just a sidekick. It's a partner in one of the solar system's most dramatic origin stories. Picture this: billions of years ago, a colossal object slammed into Pluto with such force that it shattered part of the dwarf planet, sending debris spiraling into orbit. Over time, gravity pulled those fragments together, sculpting them into Charon. This wasn't a gentle birth, it was a cosmic collision violent enough to reshape both worlds forever. Today, the two are locked in a gravitational embrace so tight they always show the same face to each other, a rare state called tidal locking. They're more like a double planet than a typical moon and planet pair, forever circling a point in the empty space between them. But Charon's surface tells an even wilder tale. Near its north pole, a splash of rusty red stains the icy landscape, a feature scientists call Mordor macula. This eerie cap isn't made of iron or dust, but of tholins, complex organic molecules formed when methane gas escaping from Pluto's atmosphere gets zapped by solar radiation and settles on Charon's frigid surface. Over eons, these compounds built up, creating a dark, reddish stain that contrasts sharply with the moon's otherwise pale terrain. It's like nature's own graffiti, a chemical fingerprint of the intimate dance between Pluto and its moon. Then there's the terrain. Charon's surface is a patchwork of canyons, some deeper than the Grand Canyon, stretching thousands of kilometers across its face. The most dramatic of these, Serenity Chasma, is a gash in the crust so vast it nearly circles the entire moon, suggesting Charon's interior once expanded as it froze, cracking the surface like an overfilled ice cube tray. But the real shocker, some of these fractures might still be active. Images from NASA, a New Horizons mission, revealed smooth plains with few craters, a sign of recent resurfacing. Scientists suspect cryovolcanoes could be at work, erupting slushy water ice mixed with ammonia or other antifreeze compounds instead of lava. If true, Charon isn't just a frozen relic, it's a world with a heartbeat, its hidden warmth occasionally bubbling to the surface. What makes Charon truly extraordinary is how much it challenges our assumptions. For decades, astronomers imagined Pluto and its moons as static, frozen fossils from the solar system's infancy. Instead, Charon serves up a dynamic world shaped by violence, chemistry, and maybe even geologic whispers of activity. From its blood-red pole to its canyon-scarred equator, this moon is a testament to the fact that even in the darkest corners of the solar system, worlds can be full of surprises, and sometimes the most dramatic stories are written in ice. While Triton steals much of Neptune's spotlight, its distant cousin Nereid tells a quieter but no less dramatic story, one written in the language of celestial chaos. This moon doesn't follow the rules. Instead of a neat, circular orbit, Nereid swings wildly around Neptune in a path so stretched it would make comets jealous. At its closest, it's just over 1 million kilometers from the planet. At its farthest, it spirals out to nearly 10 times that distance. This extreme elliptical orbit isn't just unusual, it's a cosmic red flag, signaling that Nereid's past was anything but peaceful. What could have flung this moon into such a chaotic dance? The prime suspect is Triton itself. Scientists suspect that when Triton was captured by Neptune's gravity billions of years ago, its arrival wreaked havoc on the existing moons. Nereid, once perhaps a sedate satellite in a circular orbit, might have been violently yanked and twisted by Triton's gravitational pull, like a pebble caught in the wake of a passing speedboat. Some models even suggest Nereid could be a fragment of a larger moon shattered during this cosmic reshuffling, a survivor left tumbling in the aftermath. Then there's Nereid's shape. Unlike most spherical moons sculpted by their own gravity, this world is decidedly irregular, a lumpy, potato-like body barely 340 kilometers across at its widest. Its uneven form hints that it lacks the mass to pull itself into equilibrium, frozen in a primordial state that preserves clues to the solar system's turbulent youth. Voyager 2's fleeting glimpse in 1989 revealed no surface details, but the way sunlight glinted off its surface suggested patches of fresh ice alongside darker, weathered terrain, as if Nereid's scars from its violent past are etched into its skin. The bigger mystery, Nereid's orbit isn't just eccentric, it's also tilted, another hallmark of gravitational trauma. This inclination suggests multiple close encounters, perhaps with Triton or other lost moons that were ejected entirely during Neptune's chaotic reshuffling. There's even a tantalizing possibility that Nereid isn't native to Neptune at all. Its spectral signature, the way it reflects light, resembles objects from the Kuiper belt, hinting it might have been a free-floating wanderer before Neptune's gravity snagged it. If true, Nereid could be a rare hybrid, part original moon, part captured interloper, its identity blurred by eons of celestial turmoil. What makes Nereid especially compelling is its isolation. While most of Neptune's moons cluster close to the planet or orbit in Triton's shadow, Nereid stands apart both in distance and in story. It's a relic of a time when Neptune's moon system was upended, a silent witness to the gravitational storm that followed Triton's arrival. Every irregularity in its orbit, every curve of its misshapen body, whispers secrets about the forces that shaped not just this moon, but the outer solar system itself. For now, Nereid remains elusive, its surface and composition still largely unknown. future missions to Neptune could unravel whether it's a battered survivor of an ancient moon system, a captured Kuiper Belt refugee, or something even stranger. But one thing's certain, in a solar system full of orderly orbits, Nereids' wild path is a reminder that chaos isn't just destructive, it's creative, sculpting worlds and stories we're only beginning to understand. Mars might be the red planet, but its moon Phobos is the solar system's ultimate doomsday clock. This irregularly shaped lump of rock, barely 27 kilometers across, is living on borrowed time. Every century, it creeps 2 meters closer to Mars, locked in a death spiral that will eventually tear it apart. In about 50 million years, Phobos will either crash into Mars's surface or shatter under tidal forces, forming a dusty ring around the planet. That might sound like an eternity, but in cosmic terms, it's the blink of an eye. And the scars Phobos bears today tell the story of a moon already buckling under the strain of its inevitable fate. The most striking of these scars is Stickney crater, a gaping wound that spans nearly half the moon's width. Named after the wife of astronomer Asaph Hall, who discovered Phobos in 1877, this crater is so massive the impact that created it likely came close to shattering the moon entirely. Jagged grooves radiate from Stickney like cracks in a broken eggshell, some stretching for kilometers across the surface. But here's the twist, these grooves aren't just the aftermath of that ancient collision. They're fresh, dynamic features, evidence that Phobos is still being stretched and squeezed by Mars's gravity today. Scientists once thought these grooves were simple fractures from the Stickney impact, but closer inspection revealed something stranger. The grooves align with the direction of Phobos's tidal stress, as if the moon is slowly being pulled apart like taffy. Some researchers even speculate they're early warning signs of structural failure, the first visible cracks in a moon succumbing to inevitable destruction. Adding to the mystery, the grooves are filled with fine dust, suggesting they're actively eroding, shedding material into space as Phobos inches toward its demise. Yet Phobos isn't just a passive victim. Its very existence challenges our understanding of how moons form. Most natural satellites coalesce from debris left over after their planet's formation, but Phobos's composition, dark, carbon-rich rock resembling asteroids, hints it might be a captured object snatched by Mars's gravity long ago. If true, its spiraling orbit makes even more sense. Captured moons often have unstable trajectories, destined to either escape or collide with their host planet. But the biggest question isn't how Phobos will end, it's what happens next. When the moon finally fractures, its debris could create a ring system around Mars, turning the red planet into a miniature version of Saturn, at least temporarily. Those rings wouldn't last forever, though. Over millions of years, the fragments would rain down onto Mars, leaving behind a faint trace of dust in the planet's atmosphere. Future Martian colonists might witness the final act of this cosmic drama, watching as Phobos's remains streak across the sky in fiery showers. For now, Phobos remains a stark reminder that even in the stillness of space, nothing lasts forever. Its grooves, its crater, its slow-motion suicide, all of it paints a picture of a world living on the edge, one whose very existence is a countdown to annihilation. And as we study its scars, we're not just unraveling the fate of a single moon. We're catching a glimpse of the violent, ever-changing ballet that shapes every corner of the cosmos. If Phobos is Mars's doomed moon, then Deimos is its quiet, mysterious sibling, a world that couldn't be more different despite sharing the same sky. While Phobos races toward destruction, Deimos hangs back, drifting lazily in a wide, stable orbit, almost as if it's reluctant to get too close to the drama. This tiny moon, just 15 kilometers across at its widest, looks more like a misshapen potato than a celestial body, its surface oddly smooth compared to Phobos's battered terrain. But don't let its unassuming appearance fool you. Deimos hides just as many secrets, and scientists still can't agree on where it came from or what it's made of. Take its surface for starters. Unlike Phobos, which is gouged with grooves and craters, Deimos is blanketed in a thick layer of fine regolith, dust so deep it's likely softened the edges of most impact scars over time. Images from spacecraft reveal a landscape that almost looks powdered, with only a handful of prominent craters breaking the monotony. Some researchers think this smoothness hints at an ancient past where Deimos was part of something much larger. They speculate it could be a surviving fragment of a bigger moon, shattered by a colossal impact long ago, its debris slowly settling into the dusty coating we see today. Others argue the regolith might be debris from Mars itself, ejected during meteor strikes and captured by Deimos's gravity, like a cosmic vacuum cleaner picking up planetary dust. Then there's the shape. Deimos isn't just irregular, it's bizarrely asymmetric, with one side noticeably flatter than the other. No one's entirely sure why. One theory suggests it's a relic of its formation, a leftover chunk from a violent collision that never had enough gravity to pull itself into a sphere. Another wild idea: Deimos might actually be a captured asteroid, a wandering rock snagged by Mars's gravity billions of years ago. Its composition fuels this debate. Spectral analysis shows it's rich in carbonaceous material, similar to asteroids in the outer solar system. If true, it would mean Mars's moons aren't siblings at all, but strangers brought together by chance. But the plot thickens when you look at their orbits. Phobos's death spiral makes sense if it's a captured object, but Deimos's stable, near-circular path is harder to explain. Captured asteroids usually have eccentric, tilted orbits, not the neat, almost textbook-perfect circle Deimos follows. This inconsistency has led some scientists to propose a hybrid origin. Maybe Deimos formed from debris after a giant impact on Mars, much like Earth's moon. But its material was mixed with asteroid fragments, creating this strange in-between world. The mysteries don't stop there. Recent observations suggest Deimos might be hiding traces of water, not liquid, but bound up in minerals or locked in icy pockets beneath its surface. If confirmed, it would add another layer to the moon's enigma, raising questions about how water could persist so close to the sun's glare. Future missions, like Japan's Martian Moons e-exploration (MMX), aim to settle these debates by scooping up samples and returning them to Earth. What they find could rewrite not just the story of Deimos, but our understanding of how moons form and how often the universe throws cosmic curveballs. For now, Deimos remains a quiet puzzle, content to linger in Mars's shadow while Phobos steals the spotlight. But in its smooth plains and odd shape, there's a reminder that sometimes the most unassuming worlds hold the keys to the biggest questions, and that in space, even the smallest moon can defy expectations. Jupiter's tiny moon Amalthea is a cosmic oddity, a glowing red potato spinning in the gas giant's shadow. At just 250 kilometers long, it's dwarfed by Jupiter's massive Galilean moons, but what it lacks in size, it makes up for in strangeness. Unlike the icy worlds orbiting farther out, Amalthea sports a deep reddish hue, almost like rust in space, likely caused by sulfur compounds blasted off nearby Io and dusted onto its surface over millennia. But here's the real kicker. This little moon emits more heat than it receives from the sun, glowing faintly like a dying ember in Jupiter's intense magnetic field. Scientists believe Amalthea's unexpected warmth comes from Jupiter itself. As the moon zips through the planet's colossal magnetic field at breakneck speed, electrical currents course through its metallic-rich core, a phenomenon called electromagnetic induction. These currents heat Amalthea from within, making it one of the only moons in the solar system where internal warmth doesn't come from tidal forces or radioactive decay, but from pure electromagnetic friction. The effect is so pronounced that if you could stand on Amalthea's surface, if it even has a firm surface, you might feel the faintest whisper of warmth radiating from the ground beneath your feet. Then there's its shape, a lumpy, elongated mess that looks more like a captured asteroid than a moon formed in place. Gravity measurements from the Galileo spacecraft revealed Amalthea is probably a rubble pile, barely held together by its own weak gravity, with voids making up nearly half its volume. This porous structure suggests it survived multiple collisions, absorbing impacts by compressing like a cosmic stress ball rather than shattering. Some researchers speculate its interior might contain ice or even trapped water, though the constant bombardment from Jupiter's radiation belts would make any such deposits unstable at best. What makes Amalthea truly fascinating is its role as a cosmic weather vane. Its orbit threads through Jupiter's gossamer ring, a faint band of dust likely created by meteoroid impacts on Amalthea and other small inner moons. Every time a space rock smashes into its surface, debris sprays into orbit, replenishing the ring like a celestial fountain. In this sense, Amalthea isn't just a passive moon, it's an active participant in shaping Jupiter's ring system, one impact at a time. Yet for all its quirks, Amalthea remains largely mysterious. No dedicated mission has ever studied it up close, and its faint heat signature is barely detectable from Earth. Future spacecraft might reveal whether its warmth runs deeper than we think, or if its strange coloration hides even stranger chemistry. For now, this tiny, glowing world serves as a reminder that even the smallest moons can defy expectations, and that in Jupiter's intense neighborhood, even a cosmic pebble can burn with hidden fire. Jupiter's Himalaya doesn't play by the usual rules of moon formation. While most large moons orbit neatly around their planet's equators, Himalaya bucks the trend, tracing a wide, tilted path that screams outsider. At roughly 170 kilometers across, it's the biggest of Jupiter's irregular moons, a ragtag group of celestial nomads believed to be captured asteroids rather than born and bred satellites. Unlike the Galilean moons with their icy shells and hidden oceans, Himalaya is a relic of the solar system's chaotic youth, a battered survivor from the asteroid belt that wandered too close to Jupiter's gravitational grasp and never left. What makes Himalaya especially intriguing is its darkness. Reflecting just 2 to 3% of the sunlight that hits it, this moon is as black as fresh asphalt, a stark contrast to Jupiter's brighter, ice-rich moons. That inky hue suggests a surface coated in carbon-rich compounds, similar to the darkest asteroids found in the outer belt. But here's the twist: spectral analysis reveals subtle differences from typical asteroids, hinting that Himalaya might have been altered by its time in Jupiter's neighborhood. Radiation from the gas giant's powerful magnetosphere could have baked its surface over eons, darkening it further or even triggering chemical reactions we don't yet understand. Then there's the mystery of its orbit. Himalaya doesn't travel alone. It leads a loose family of smaller moons, all sharing similar tilted paths. Astronomers call this the Himalaya group, and their synchronized orbits suggest a violent past. The leading theory: a single, larger asteroid was shattered by a catastrophic collision long ago, leaving Himalaya as the largest fragment while the rest became its orbital entourage. Supporting this idea, observations show Himalaya's shape is irregular and slightly elongated, as if it's a piece of a puzzle that once fit into a bigger whole. But Himalaya's story doesn't end there. Unlike Jupiter's inner moons, which are constantly sculpted by tidal forces, Himalaya orbits far enough to avoid such drama. Its surface, pocked with ancient craters, is essentially frozen in time, a snapshot of the early solar system's bombardment phase. Yet even here, surprises lurk. In 2016, astronomers spotted a faint, dusty ring around Himalaya, likely created by micrometeoroid impacts kicking up debris. It's a delicate feature, one that underscores how even the most seemingly static worlds are still active in subtle ways. The bigger question is what Himalaya can teach us about planetary migration. Its existence hints at a time when Jupiter's gravity reshaped the solar system, flinging some asteroids into the sun or outer darkness while ensnaring others like Himalaya into permanent orbits. Future missions could analyze its composition to uncover clues about the primordial asteroid belt, or even test whether it truly is a captured relic or something more exotic. For now, this dark, distant moon remains a shadowy sentinel, a reminder that sometimes the most unassuming objects hold the keys to the solar system's untold stories. Saturn's moon, Phoebe, doesn't just orbit the planet, it defies it. While most moons dance obediently in the same direction as their planets spin, Phoebe rebels, hurtling backward in a retrograde orbit that marks it as an outsider. This isn't just a quirk, it's a smoking gun. Phoebe didn't form alongside Saturn, it was stolen. Scientists believe this dark, craggy moon was once a free-roaming denizen of the Kuiper belt, that icy realm beyond Neptune, until Saturn's gravity snatched it billions of years ago and forced it into servitude. And its cosmic heist left clues everywhere, from its battered surface to its role in painting another moon jet black. First, there's the darkness. Phoebe's surface is one of the least reflective in the solar system, absorbing almost all sunlight that touches it. But this isn't just any blackness, it's rich with complex organic molecules, the kind that form the building blocks of life. When NASA Cassini spacecraft flew by in 2004, its instruments detected compounds like hydrocarbons, cyanides, and even polycyclic aromatic hydrocarbons (PAR, the same sticky, carbon-heavy substances found in comet dust and deep space nebulae. These aren't just stains, they're relics of the solar system's primordial chemistry, preserved in Phoebe's frozen crust like a time capsule from the era of planet formation. Yet Phoebe's most dramatic legacy might be written on another moon, Iapetus. That stark black and white divide on Iapetus, Phoebe's fingerprints are all over it. As Phoebe orbits backward, micrometeoroid impacts blast dark material off its surface, creating a faint ring of dust that spirals inward over millennia. Iapetus, plowing forward on its orderly path, collects this debris like a windshield gathering grime, but with a twist. The dark material absorbs sunlight, warming Iapetus's surface just enough to trigger a runaway feedback loop. Ice sublimates, leaving behind even more concentrated dark residue, while the untouched trailing hemisphere stays blindingly bright. In essence, Phoebe isn't just a moon, it's a cosmic graffiti artist tagging its neighbor from millions of kilometers away. But Phoebe's surprises don't stop there. Its surface is a rugged nightmare of cliffs and craters, with some impacts so violent they've exposed bright water ice beneath the dark veneer like scars revealing bone. These fresh wounds suggest Phoebe's interior might be far icier than its coal-black exterior implies, a remnant of its origins in the Kuiper belt's deep freeze. Even its shape hints at chaos, irregular and lumpy, as if it's a pile of rubble barely holding together after eons of collisions. The real magic, though, lies in what Phoebe represents, a messenger from the solar system's edge. Its composition, its orbit, even the way it's dusting Iapetus with organic compounds, all of it offers a glimpse into the raw materials that built the outer planets. Future missions might one day sample Phoebe's surface directly, digging into those carbon-rich layers to uncover secrets about how life's ingredients spread across the cosmos. For now, this rogue moon remains a dark, enigmatic outcast, a reminder that sometimes the most revolutionary discoveries come from the things that refuse to follow the rules. Saturn's moon, Dione, wears its history like a ghostly veil. From a distance, its most striking features are the bright, wispy streaks that stretch across its icy surface, resembling delicate brushstrokes on a cosmic canvas. But these aren't just random blemishes, they're scars. When the Cassini spacecraft flew close in 2005, it revealed the truth. These ethereal wisps are actually towering cliffs of ice, some hundreds of meters high, gleaming in sunlight as they fracture and reflect light like shattered glass. These cliffs tell a story of a moon that was once geologically alive, its crust cracking under stresses we're only beginning to understand. What's even more fascinating is what might lie beneath that icy shell. Gravity measurements from Cassini hinted at a subsurface ocean, a hidden layer of liquid water sloshing between Dione's rocky core and its frozen exterior. Unlike the turbulent seas of Enceladus or Europa, Dione's ocean, if it exists, would be ancient and still, a relic of past tidal heating from Saturn's gravitational pull. Some scientists speculate this ocean could have persisted for billions of years, a quiet abyss where chemistry played out in slow motion. The clues are subtle: slight wobbles in Dione's orbit, magnetic field disturbances, and even the faintest whispers of charged particles caught by Cassini's instruments, all pointing to the possibility of liquid water trapped in the dark. Then there's Dione's relationship with Saturn's rings. This moon doesn't just orbit in isolation. It dances with the planet's iconic rings, shaping them in ways that defy expectations. Dione shares its path with two smaller moons, Helene and Polydeuces, trapped in gravitational sweet spots known as Lagrange points, but its influence stretches farther. Scientists believe Dione's gravity tugs on microscopic particles in Saturn's E-ring, shepherding them into delicate structures that ripple outward like waves in a pond. Some of these particles might even originate from Dione itself, icy grains blasted into space by micrometeoroid impacts, adding to the ring's ethereal glow. The most haunting mystery, though, is Dione's past activity. Those wispy cliffs, they're not uniformly distributed. They cluster on one hemisphere, as if the moon froze mid-transformation, preserving a snapshot of its most violent era. Some researchers think Dione was once as geologically dynamic as Enceladus, with cryovolcanoes conos or even plumes venting material into space. Over time, as its orbit shifted and tidal forces waned, the moon fell silent, leaving behind these icy monuments to its former self. Dione might not scream its secrets as loudly as some of Saturn's other moons, but that's what makes it so compelling. It's a world of quiet contradictions, a frozen surface hiding possible liquid depths, a seemingly static moon that once writhed with activity, and a gravitational puppeteer shaping one of the solar system's most dazzling features. Every crack, every wisp, every subtle orbital quirk is a clue to a story we're still piecing together, one that reminds us even the most unassuming worlds can hold universes of mystery. Saturn's moon Rhe might look like just another icy relic from the outside, a pale, cratered world frozen in time. But beneath that weathered exterior lies a series of mysteries that have kept scientists guessing for decades. For starters, Rhe's surface is one of the oldest in the solar system, its terrain pockmarked with impacts so ancient they stretch back nearly 4 billion years. Some of these craters are hundreds of kilometers wide, scars from a time when the solar system was a chaotic shooting gallery. Yet despite this battering, Rhe has held onto something unexpected, a whisper-thin atmosphere of oxygen and carbon dioxide, so delicate that if you stood on its surface, you'd need an impossibly sensitive instrument just to detect it. This isn't an atmosphere in the traditional sense. It's more like a fleeting exhalation, molecules clinging to the moon's surface before drifting into space. Where does this oxygen come from? The leading theory points to Saturn's powerful radiation belts. High-energy particles constantly slam into Rhe's icy surface, splitting water molecules into hydrogen and oxygen. The lightweight hydrogen escapes while the heavier oxygen lingers, creating this ghostly envelope. It's a process that's been compared to cosmic alchemy, turning ice into air through sheer force of bombardment. But the real intrigue lies in what this means for other icy moons. If Rhe, a seemingly quiet, geologically dead world, can harbor traces of oxygen, could others? And if so, what does that imply for the chemistry of their hidden oceans? Then there's the puzzle of Rhe's rings, or the lack thereof. In 2008, data from the Cassini spacecraft hinted at something extraordinary, a possible ring system encircling the moon. Scientists spotted peculiar dips in the density of electrons around Rhe, a telltale sign of material absorbing charged particles. The explanation, rings similar to Saturn's but far fainter, might be lurking just beyond detection. Yet follow-up observations revealed nothing, no visual confirmation, no clear evidence of the debris that should accompany such rings. Some researchers now argue those initial readings were a fluke, caused by temporary shifts in Saturn's magnetic field. Others cling to the idea that these rings are real but made of such fine, sparse material that they're nearly invisible. The debate doesn't end there. Even if Re lacks rings now, it might have had them in the past. The Moon's equatorial region is slightly flattened, a potential relic of a bygone disk of debris that once orbited it. Over eons, that material could have collapsed onto Re's surface or scattered into space, leaving behind only gravitational echoes of its existence. Future missions might settle the argument once and for all, but for now, Re keeps this secret close. What makes Re truly fascinating is how it defies expectations. It's a world that should be frozen in time, yet it breathes oxygen into the void. It's a moon that appears solitary, yet might have once worn rings like its planetary parent. And while it lacks the geysers of Enceladus or the methane lakes of Triton, it holds its own kind of quiet revolution, proof that even the oldest, most battered worlds can still surprise us. Every crater, every wisp of atmosphere, every unresolved mystery is a reminder that in space, the past is never truly silent. It's just waiting for the right moment to speak. Oberon, the outermost of Uranus's major moons, looks like a fossil frozen in time. Its dark, heavily cratered surface tells the story of a world that's endured billions of years of cosmic bombardment without erasing the evidence. The craters here aren't just plentiful, they're sprawling, some with bright rays of ejected material stretching hundreds of kilometers across the landscape, as if the moon was splattered with pale paint. These aren't fresh scars, though. Oberon's craters are ancient, their edges softened by eons of micrometeorite erosion, and the slow buildup of dark, organic-rich material that seems to blanket much of the moon. Yet despite its battered appearance, Oberon might be hiding secrets beneath that icy crust. Gravity data from Voyager 2 hints at a possible subsurface ocean, a layer of liquid water trapped between the moon's rocky core and its frozen exterior. Unlike the turbulent seas of Europa or Enceladus, this ocean, if it exists, would be frigid and sluggish, kept liquid not by tidal heating but by antifreeze compounds like ammonia mixed into the water. The idea isn't as far-fetched as it sounds. Even in the bitter cold of the outer solar system, certain chemical cocktails can lower water's freezing point dramatically, creating pockets of liquid where there should only be ice. The real enigma, though, lies at Oberon's poles. Scattered across its otherwise somber surface are patches of startling brightness, concentrated near the crater rims and along the edges of vast chasms. Some scientists think these gleaming spots could be fresh ice exposed by recent impacts or geological activity, while others speculate they're deposits of carbon dioxide frost, clinging to the coldest regions of the moon like interstellar frost on a windowpane. There's even a wilder theory. These bright patches might be evidence of cryovolcanism, where slushy water laced with ammonia erupted from below and froze in the vacuum of space, leaving behind gleaming trails like celestial snail tracks. What makes Oberon especially intriguing is how little we know. Voyager 2's flyby in 1986 gave us only fleeting glimpses, and no mission has returned since. Future spacecraft might reveal whether that subsurface ocean is real, or if those polar bright spots are the work of some unseen process quietly reshaping the moon's surface. For now, Oberon remains a silent sentinel at the edge of Uranus's domain, a world that wears its age visibly, yet keeps its deepest mysteries locked beneath the ice. Every crater, every glint of light is a clue to a history we've only begun to piece together. Triton, Uranus's largest moon, is a world of contradictions, a frozen sphere etched with scars that whisper of a violent, active past. Its most striking features are the gargantuan canyons crisscrossing its surface, some stretching over 1,500 kilometers long and plunging 12 kilometers deep. To put that in perspective, if you stood at the edge of one of these chasms, Earth's Grand Canyon would look like a scratch in comparison. These fractures, named after Shakespearean heroines like Gertrude and Messina Chasmata, aren't just random cracks. They're evidence of a moon that once writhed with internal forces, its icy crust splitting apart as if something beneath was straining to break free. What could have caused such colossal upheaval? The leading theory points to expansion. As Titania's subsurface ocean froze billions of years ago, the growing ice would have pushed outward, fracturing the crust like an overfilled water balloon. But there's a twist. Some of these canyons show smooth floors, almost as if they were flooded by slushy water or soft ice that later refroze. This suggests Titania didn't just crack and settle. It might have experienced fleeting eruptions of cryovolcanism, where liquid water or ammonia-rich slurries ooze to the surface before freezing solid in the vacuum of space. Then there's the tantalizing possibility of life. Titania's interior almost certainly hosted a liquid ocean in its past, and some models suggest pockets could still persist today, kept warm by radioactive decay in its rocky core. Unlike Europa or Enceladus, where tidal heating keeps oceans churning, Titania's potential sea would be stagnant and ancient, a slow, cold abyss where chemical reactions play out over eons. Yet even here, in near-total darkness, extremophiles could find a way. On Earth, microbes thrive in subglacial lakes like Antarctica's Lake Vostok, surviving on mineral-rich water and geothermal heat. If Titania's ocean contains even trace amounts of ammonia or salts to lower its freezing point, it might still be a viable, if inhospitable, haven for simple organisms. The Moon's surface adds another layer of intrigue. Unlike its sibling Oberon, Titania's terrain is relatively smooth in places, with fewer large craters, a sign of past resurfacing. Some regions show odd, pitted landscapes that look like they've been melted and refrozen, while others feature sprawling plains dotted with enigmatic ridges. These features hint at a complex geological history, possibly involving tidal forces from Uranus before the Moon's orbit stabilized. What makes Titania especially compelling is how little we've seen of it. Voyager 2's flyby in 1986 captured only a fraction of its surface, leaving vast swaths unexplored. Future missions could reveal whether those smooth canyon floors are truly the remnants of cryovolcanic flows, or if Titania's fractures hide even deeper secrets. For now, this battered, enigmatic moon stands as a testament to the dynamic forces shaping even the coldest worlds, and a reminder that where there's ice, there's often more than meets the eye. Umbriel might be the darkest of Uranus's major moons, but don't mistake its shadowy appearance for a lack of intrigue. Cloaked in a blanket of near-black material, this moon reflects just 16% of the sunlight that hits it, darker than fresh asphalt on Earth. Yet against this gloomy backdrop lies one of the solar system's most puzzling features, a razor-sharp, gleaming ring at the bottom of Wonder Crater, a perfect circle of brightness staring out from the shadows like a cosmic bullseye. The contrast couldn't be more striking. While most of Umbriel's surface is a uniform sea of ancient, cratered terrain, this one spot shines with the brilliance of freshly fallen snow, and nobody's entirely sure why. Wonder Crater itself is a sprawling impact site, stretching 130 kilometers across, large enough to swallow entire cities. But unlike the jagged peaks or rough floors of most craters, Wonder's basin is eerily smooth, with that mysterious ring hugging its inner edge. Some scientists think the bright material could be exposed ice, blasted clean by the impact that created the crater. Others speculate it might be deposits of carbon dioxide frost, condensed from Umbriel's tenuous atmosphere and trapped in the crater's perpetual chill. There's even a wilder theory. The ring could mark the remnants of a cryovolcanic eruption, where slushy water or ammonia-rich fluids seeped up through fractures in the moon's crust before freezing solid in the vacuum of space. What makes Umbriel's darkness just as fascinating as its lone bright spot is the sheer consistency of it. Unlike moons with patchwork terrains or dramatic color variations, Umbriel's surface is almost monotonously dark, as if someone dipped the entire world in ink. The leading explanation points to a process called space weathering. Over billions of years, charged particles from Uranus's magnetosphere and cosmic radiation may have bombarded Umbriel's surface, breaking down organic compounds in the ice and leaving behind a layer of dark, complex hydrocarbons. It's like the moon has been slowly baked by the universe itself, its once pristine ice transformed into a carbon-rich crust. Yet even here, there are whispers of hidden activity. Some researchers argue Umbriel's smooth plains, particularly near its smaller craters, hint at past resurfacing, as if slushy material oozed out and refroze, erasing older scars. If true, it would mean this moon wasn't always the silent, unchanging relic it appears to be. There's also the curious case of its shape. Unlike most spherical moons, Umbriel is slightly flattened at the poles, a relic of its formation, or perhaps the gravitational tug of war with Uranus and its sibling moons. The biggest mystery, though, is why Wanda's bright ring exists in isolation. If impacts or internal processes exposed ice elsewhere, why hasn't it been darkened by the same space weathering that colored the rest of the moon? One possibility is that Wanda is young by geological standards, its bright features simply not old enough to have been stained. Another is that the crater's unique geometry, its depth and steep walls, shields the ring from radiation, preserving its brilliance like a cosmic time capsule. Umbriel may lack the geysers of Enceladus or the methane lakes of Triton, but in its own way, it's just as enigmatic. A world where darkness dominates, yet one defiantly bright ring refuses to fade. A reminder that even the most unassuming moons can guard secrets that challenge everything we think we know. Ariel, Uranus's brightest moon, looks like a celestial jigsaw puzzle that's been cracked and reassembled by invisible hands. At first glance, its surface is a bizarre mix of youthful smoothness and violent scars. A landscape where vast, icy plains stretch uninterrupted for hundreds of kilometers, only to be sliced apart by deep, snaking valleys that resemble the cracks in a frozen lake. These aren't just random fractures. Some of these canyons, like the sprawling Kachina Chasmata, plunge over 10 kilometers deep enough to swallow Mount Everest whole, with walls so steep they'd make even the most daring rock climber hesitate. Yet between these gashes, Ariel's terrain is eerily unblemished, as if someone took a cosmic spatula and smoothed over entire regions, erasing craters that should have accumulated over billions of years. This strange duality points to a dramatic past. Scientists believe Ariel was once geologically alive, its interior churned by tidal forces from Uranus's gravity. Unlike the steady heating Europa or Enceladus experience today, Ariel's activity was likely sporadic, triggered by orbital shifts or resonances with neighboring moons that have since faded. The clues are written in those valleys. Many appear to be tectonic graben, stretches of crust that sank between parallel faults as the moon's interior expanded or shifted. Others show signs of ancient flooding, their floors unnaturally smooth, as if they were once rivers of slushy ice or cryolava that oozed up from below before freezing solid. Then there's the cryovolcanism. While Ariel's volcanoes wouldn't spew molten rock, they might have erupted a bizarre cocktail of water, ammonia, or methane ices, slurries thick enough to sculpt the landscape as they flowed. Some of the moon's smooth plains, particularly near the terminator where shadows accentuate subtle textures, bear faint, flow-like ridges reminiscent of terrestrial lava fields. These could be the frozen remnants of cryovolcanic eruptions, where mile after mile of icy magma coated the surface before flash freezing in the vacuum of space. Even more telling are the odd, pitted domes scattered across Ariel's surface, possible relics of vents where these alien geysers once roared to life. But what really baffles researchers is the timing. Ariel's surface is far younger than Umbriel's or Oberon's, with crater counts suggesting some regions were resurfaced as recently as 1 billion years ago, a blink of an eye in geological terms. How could a moon so small and distant muster the energy for such renewal? One theory suggests Ariel's orbit was once more eccentric, creating stronger tidal flexing that heated its interior before gradually circularizing. Another proposes that its crust is rich in antifreeze compounds like ammonia, lowering the melting point of its ices and allowing sluggish, cryovolcanic activity to persist long after other moons froze solid. The most tantalizing question, though, is whether Ariel's story is truly over. While no plumes or geysers have been spotted, the moon's smooth patches and odd geological features hint that its interior might not be entirely silent. If even a sliver of liquid persists briny, ammonia-laced water trapped between layers of ice, it could mean Ariel isn't just a relic of past activity, but a world capable of surprising us again. Future missions might one day map its hidden layers, searching for the faint tremors of a moon that refuses to fade quietly into the cosmic night. Until then, Ariel remains a paradox, a world both ancient and youthful, its scars and silences whispering of forces we've only begun to understand. Neptune's moon Proteus is the cosmic equivalent of a battered warrior, a dark, misshapen mass of rock and ice that barely survived the violence of its own creation. At roughly 400 kilometers across, it's Neptune's second largest moon, yet it's so irregular and cratered that it looks more like a colossal asteroid than a proper satellite. Unlike the spherical moons sculpted by their own gravity, Proteus is a lumpy, potato-shaped relic, its edges jagged and uneven as if it was hastily cobbled together from cosmic debris. But what really sets this moon apart isn't just its rough appearance, it's the fact that we almost missed it entirely. Despite its size, Proteus eluded Earth's telescopes for centuries, hidden in Neptune's glare until Voyager 2's historic flyby in 1989. The reason: its surface is one of the darkest in the solar system, reflecting just 6% of the sunlight that hits it, darker than charcoal. Combine that with its chaotic orbit and proximity to Neptune's luminous atmosphere, and it's no wonder ground-based observers never spotted it. Voyager's cameras, however, revealed a world pockmarked with craters so vast they've warped Proteus's already irregular shape. The most prominent, Pharaoh's crater, stretches a staggering 230 kilometers across, so large the impact that created it likely came close to shattering the moon completely. But Proteus's scars aren't just evidence of past violence, they're clues to its resilience. The moon's density suggests it's not a loose rubble pile, but a solid, compact body that somehow endured eons of brutal collisions without disintegrating. Some scientists think its dark, carbon-rich surface acted like a cosmic shock absorber, with the material compacting under impacts rather than fracturing. Others speculate its interior might be laced with stronger, metallic minerals that helped it hold together against the chaos. Yet Proteus's biggest mystery isn't its survival, it's why Neptune's smaller moon, Triton, gets all the attention. Triton's geysers and retrograde orbit make it a celebrity, but Proteus is the quiet workhorse, its gravity shaping Neptune's ring arcs and shepherding dust particles into delicate structures. Without Proteus, Neptune's faint rings might not exist in their current form, making this battered moon an unsung architect of the planet's delicate jewelry. Future missions might reveal whether Proteus hides any secrets beneath its battered shell, ancient ices, trapped organics, or even hints of past tidal heating. For now, it remains a testament to the solar system's untidy origins, a world where chaos and endurance collide, proving that sometimes the most fascinating stories are written not in perfect spheres, but in the scars of survivors. From the fiery volcanoes of Io to the methane rivers of Titan, these 25 moons have taken us on a tour of the solar system's strangest corners. We've explored worlds with hidden oceans, chaotic orbits, and surfaces that defy logic, each one rewriting the rules of what a moon can be. Think about it. Europa's icy shell concealing twice the water of Earth's oceans, Triton's backward dance as it hurtles toward destruction, or Miranda's jumbled terrain like a puzzle missing half its pieces. These aren't just rocks in space, they're time capsules, laboratories, and even potential havens for life. And the wildest part, we've barely scratched the surface. Every mission, every telescope image seems to unveil new mysteries like Dione's ghostly wisps or the unexplained glow of Amalthea, reminding us how much we still have to learn. What ties these moons together isn't just their strangeness, but the questions they force us to ask. Why does Hyperion tumble like a drunken asteroid while Mimas wobbles like a spinning top? How did Iapetus become a celestial yin-yang, half-stained black and half-gleaming white? And what secrets lie beneath the frozen crusts of Rhe or Teutonia, where ancient oceans might still linger? These puzzles aren't just academic, they're clues to the solar system's turbulent past, and maybe even our future. Imagine standing on Charon's rust-stained plains, watching Pluto eclipse the sun, or diving into Enceladus's plumes to sample its alien sea. These worlds aren't static backdrops, they're protagonists in a story billions of years in the making. The best part, this story isn't over. Right now, probes like Europa Clipper and Dragonfly are preparing to launch, promising answers, and undoubtedly more questions. Who knows what we'll find next? Maybe microbial life swimming in Enceladus's depths, or geological activity on moons we once thought were dead. The universe has a way of surprising us when we least expect it. So stay curious, look up at the night sky and remember, every planet's shadow hides a moon with its own secrets, waiting to be uncovered. If these cosmic oddities left you as awestruck as they did us, hit that subscribe button to dive deeper into the universe's mysteries. And drop a comment below which moon captivated you the most, the icy enigma of Europa, the volcanic fury of Io, or maybe the doomed beauty of Phobos. The conversation doesn't end here. The solar system is vast, mysterious, and far stranger than fiction, and together we're just getting started.